Well, good morning, good afternoon, everyone. Welcome in from across the continent and beyond today for another exciting Exploring by the Seat of Your Pants broadcast. For those of you joining us for the first time, we're all about bringing conservation, adventure, and science into classrooms around the world. And you're catching us on a bittersweet day. Bitter because we are wrapping up an epic series, and sweet because it's been a pretty great series. We are wrapping up our World Underwater Scholarship Society epic 5-part mini-series. You can check out all the programs on that webpage below or on our YouTube channel as well. Lots to explore and discover there. This has been an effort to showcase some of the most incredible alumni of the Our World Underwater Scholarship Society's program, which basically provides young, enterprising, incredible ocean storytellers and scientists the chance to shadow and get involved in cool ocean careers on a path towards greater and bigger things. Now, we've had the chance to feature some really amazing people protecting tiger sharks, coral reefs, and more. I really encourage you, check out the scholarship website itself. This has been a partnership between us, them, the Story Collider, in which there's a live show in New York soon, all made possible by Rolex's Perpetual Planet Initiative. So a lot of organizations coming together for this special series. Now, we are wrapping up in style in New York with Joanna Smart, who's joining us today from Australia. That's where she's from. She's hanging out in New York from Australia. Sorry, that was poorly said. Joanna gets to study the ocean from space. How do you do that? What is it all about? This is actually a topic we've come back to a few times at Exploring by the Seat of Your Pants because it is just so cool. So how do we blend the cosmos and the deep sea? Well, we're going to find out with Joanna. Thank you so much for joining us today, and welcome to the broadcast.
Thank you so much for having me. I'm excited to be here.
I know you've got a lot to share with us, so I've put myself in the background. I'm going to zip my lip. If you want to dive in and blow our minds with all the cool stuff you get up to, by all means, bring up the presentation and let's do this thing.
Perfect. Let me just share my screen with everybody so that you guys can all see what I've got today. All right. How's that? Can everyone see?
You are perfect. Couldn't be better.
Awesome. Well, thanks for joining me today from wherever in the world you might be. My name is Joanna Smart. I'm from Australia, as you can probably tell by my accent. And today I'm going to be talking about how we are exploring our oceans from outer space. So I'm a marine scientist and ecologist. This means that I get to spend my time learning about and exploring our underwater world. If you have a look at the photos on this slide, this is some of the cool stuff that I get to do in my job. So all of these photos are me underwater, which is pretty cool. I get to explore the deep sea, the shallow sea, seaweed, seagrass, coral, all in the name of work. So in this photo, you can see up there in the greeny background one, that's actually me scuba diving in Scotland, studying the kelp. However, not all of our job is full of field work. I also spend a lot of time in the office analyzing all the data we collect on computers and writing up scientific papers and reports. So I'm currently based at the University of Queensland in Australia. So if you have a look at where that little red circle is, that's where the University of Queensland is. It's in Brisbane. And did you know that Brisbane is actually a 15-hour flight from Los Angeles and about a 20 to 24 hours of travel from the east coast of the USA? So today I'm currently in New York City for some Our World Underwater Scholarship Society events, and I only arrived last night, so I might be a little bit jet lagged, so please forgive me if I'm a bit slow on some of my words. So what do? I study human impacts on marine ecosystems. So this means that it's my job to work out how all kinds of activities humans do, like building bridges, dredging, polluting the water, and farming fish, impact all the different ecosystems of the ocean. So whilst a lot of people think that marine science is all swimming with dolphins and turtles, that's not always the case. So some of these photographs here are me hard at work. And the two that you can see in the bottom left corner that are sort of with the more bluey background where you can't quite see the person, that is actually me diving on a sewage treatment pipeline. So that's where all the stuff that you put down the toilet, it gets treated and then pumped into the ocean. So it's not all about dolphins and turtles. So currently I'm using remote sensing to study seagrass and coral communities. So remote sensing is where we use equipment that operates from a distance. So this can include aeroplanes, drones, or satellites to learn about the environment. And this can be really useful because it allows us to study areas we can't usually reach or cover really large distances really quickly. So, with this sort of technology, we might be able to study the whole size of America in one day, which is pretty cool. So, both coral reefs and seagrass beds are really important for our planet. This is a photograph I took of some seagrass off the coast of California. Now, the seagrass is only about 10 inches high, but it can cover really large areas similar to paddocks or grass meadows on land. And although it's small and inconspicuous, it plays a really important role in our ecosystem. Here is a map of seagrass beds all over the world, and the green areas show where we currently know where seagrass is. So I want everyone in your classrooms today to have a look at this map and work out if there's any seagrass near where you're currently located. So as you can see, it covers a pretty big area. There's a lot around the coast of North America, a lot around Europe, Asia, and Australia. And the only places it doesn't grow is in the Arctic and in Antarctica. And all of this seagrass plays a really important role in stabilizing the sediment and sand. So the roots of the seagrass help keep the sand together and stop it from washing away. This protects our shoreline and stops it from eroding when big storms or cyclones occur. The other really cool thing that seagrass does is it's an important home for lots of different marine animals. So I know that most of you guys watching today are somewhere in North America. So you might be familiar with this guy on the left. He's the manatee. But did you know we also have a really similar animal in Australia called the dugong? Like manatees, dugongs eat seagrass. So they're basically big underwater cows. But the main difference between a manatee and a dugong is manatees are a lot fatter and they have a round tail, where dugongs have tails that's shaped more like a mermaid. And it's not just manatees and dugongs that seagrasses are important for. Have a look at this photo here and see if you recognize any of the animals. So on the top, we've got a turtle, a tiger shark, a seahorse, and an alligator. And all of these animals rely on seagrass beds in some way. They all either eat seagrass themselves or they eat animals that rely on seagrass for survival. So the other part of my work is looking at coral reefs, and coral reefs are really important for our oceans. Now, I've got a video here from the Natural History Museum in London that explains a bit about why coral reefs are important. So what we might do is switch to Jesse's screen real quickly so he can play that video with sound for everybody.
Under the waves all over the world, there are spectacular ecosystems. Corals are tiny little animals that together can form huge reefs, spanning hundreds of kilometers, teeming with diverse life. So let's take a look. The oldest corals lived 450 million years ago. That's long before dinosaurs, who clock in from around 240 million years ago. The first members of the human family only appeared around 7 million years ago. Thousands of species can be found living on one coral reef. For example, the Great Barrier Reef contains over 400 species of coral, 1,500 species of fish, 4,000 species of mollusk, and 6 species of turtle. And because of this amazing biodiversity, we're starting to discover that there is a lot we can learn from coral. Coral extracts have been used to develop treatments for asthma, arthritis, cancer, and heart disease. It's been estimated that coral reefs provide a global value of £5.7 trillion each year, including from fishing and tourism. More than 500 million people worldwide depend on reefs for food, jobs, and coastal protection. The ridges in coral reefs can reduce wave energy by up to 95%, providing crucial protection from threats such as tsunamis. If we were to travel back in time 40 million years, the most diverse place on Earth was somewhere between where London and Paris are now. Today, the Coral Triangle in Southeast Asia holds that claim, and until the 13th of September in In London, the wonder and diversity of these spectacular underwater ecosystems are on display at the Natural History Museum's major exhibition, Coral Reefs, Secret Cities of the Sea.
All right, so that video is pretty cool. It tells us a lot about why coral reefs are really important. But unfortunately, coral reefs and seagrass beds are both under threat. A lot of activities we do as humans impact these ecosystems. So, climate change, overfishing, dredging, and agricultural runoff can all impact how these systems survive. So, if you have a look at the photo we've got here, the far photo on the left shows a healthy coral reef. The middle photo shows a bleached coral reef. So coral reef bleaching happens when the water gets too hot and the coral expel their symbiotic little animals that help keep them fed. And if a reef remains bleached for too long, it dies. And that's what the photo on the far right, which is when algae grows over the reef. And events like this are happening all over the globe for both coral and seagrass meadows. So we need to study these systems to work out how and why they are changing. But coral reefs and seagrass beds are really, really big. So this picture here shows us how big the Great Barrier Reef in Australia is compared to Europe and North America. So if we had to map all of that area just using scuba divers, it would be like swimming all the way from Mexico to Canada. And that's just for one reef system. So this is one of the challenges I work on. How do we know what's happening to them when the area they cover is so large? Well, to do that, we need to map them from outer space. And we can use satellites. So this photo here shows all of the active satellites around the Earth. Now, I will say that the satellites have been made a bit bigger for the picture purpose, so they're not actually that big, but it gives you an idea of just how busy outer space is these days. So there's currently about 9,900 satellites in orbit, and that doesn't even count the ones that are no longer being used or are decommissioned. So the actual number is much higher than that. 105 different countries have satellites, and they're used for all kinds of things, for telephone connection, GPS signal, surveillance, and predicting the weather. And the reason I can actually speak to you in your classrooms today is because I'm connected to satellites. But luckily, we can also use these satellites to map coral and seagrass. Of the satellites that are orbiting the Earth, more than 1,000 are used for observing our environment. These can include satellites that take pictures or aerial photos, ones that monitor carbon dioxide, water quality, plant growth, agriculture, cloud formation, and the weather. The picture here shows all of the satellites that NASA currently has just to map and monitor our environment. And we can also use these for coral and seagrass. So how do we do this? You're probably all wondering by now. Well, we can't simply use pictures like Google Earth. This is because it's really difficult to distinguish different types of coral and seagrass from a photograph. So the photograph I've got here is an aerial picture of a coral reef. And all of those little specks that you can see are coral colonies. And it's really difficult to distinguish them. Some are the same color, but are actually different species. And in addition, some are deeper underwater, so it's harder to see. So what we do is we have a look at what our eyes can't see. So all of the light we see around us is actually made up of all different colors. And we can see the objects around us because the light hits those objects and is reflected into our eyes. Different objects reflect different colors of light. So leaves are green because they reflect green light, and the ocean is blue because it reflects blue light. The human eye can see 3 different colors: red, blue, and green. All the other colors we can see are a combination of these primary colors. And this is because we have pigments in our eyes that can detect these colors. But other animals have different pigments in their eyes and they see color differently. So this photo here is an example of what a flower might look like through the eyes of different animals. So we can see as a human, we see that as a yellow flower, but a butterfly can actually see all the colors that we can see, as well as ultraviolet light, which our eyes aren't sensitive to. So they actually see a different pattern on the flower. Dogs, if you've got a pet dog at home, some of them can only see blue and yellow and some UV light. So to them, the flower also looks really different. And bats can't actually see color at all. They see the world in black and white. But some animals in the ocean can see even more colors. For example, this guy here is a mantis shrimp, and I think they're pretty cool. Like, they're pretty cool animals. They live in burrows on the sand on coral reefs, and look at that color. They're like a rainbow. But when scientists look at the eyes of the mantis shrimp, they found that it could see the world through 12 different colors, and they can detect UV light. So this meant that scientists asked why. Why can it see in so many different colors? So they looked at a coral reef through all the different colors that the mantis shrimp could see. And they found that there's actually all different wavelengths of light being emitted by animals under the sea. We just can't see them ourselves. So this picture here shows what reef fish look like under UV and infrared light. So if you have a look at the picture there, you can see that the fish, the way we see him, he's got the yellow stripe on the bottom. But if we look at him under UV light, all of a sudden he glows with all these different colors. We aren't really sure why marine animals reflect different light colors. Maybe it's to ward off predators or to guard their territory. But I think it's pretty cool to think that there's a whole world out there that's invisible to us as humans. And this phenomenon is also really useful for me because different corals and seagrasses emit different colors of light, which is unique to them. And we call this a spectral signature. So if you have a look at this picture here, you can see seagrass on the left, coral in the middle, and sand on the right. The graphs down the bottom, don't worry too much about the numbers and the graph, but the point I'm trying to make is each of these things has a spectral signature, which is like a fingerprint, and it's unique to every individual species. So that's pretty handy for us. And we measure these fingerprints with an instrument called a spectrometer. So this picture here is me scuba diving a couple of months ago on Heron Island, which is in the Great Barrier Reef. And I'm holding the big spectrometer there. The spectrometer measures all of those individual invisible colors that we can't see. So we point it at lots of different things, like all the different species of coral and seagrass, and it gives us that unique fingerprint for each of those species. Then there's a similar instrument that's mounted to a satellite orbiting the Earth. And we get satellite images of the area we would like to map. We then compare them to what our readings in the field were, so we can classify each part of an image depending on what its unique fingerprint was. So this animation here is showing one of the satellites traveling around the world, and it's collecting all of that different color information from the Earth. And then as it does this, we can then compare that color information to what we collected in the field. And I think that's pretty cool. And as a fun fact for everybody, some of these satellites are only the size of a microwave. So they're not actually very big. So as well as satellites, this can also be done from aeroplanes or drones. So as the spectrometer passes over an area, it collects that fingerprint and records the information. From this information, we can then create all kinds of maps. And so what do we create? I create maps of coral and seagrass cover. So as an example, all of these photos here were taken on Heron Island on the Great Barrier Reef, which is where I get to spend a lot of time working. So Heron is a really cool area. There are more than 120,000 birds on this tiny island. And this makes it very, very loud at nighttime when they come into roost. It's also home to a lot of turtles who lay eggs on the island and nest in the sand. And this is what Heron Island looks like from outer space. It was taken with a NASA satellite. The island is that little green dot there, surrounded by the beach, which is white. The light blue area is the fringing reef where all of the coral is. Now, are you ready? I'm going to overlay a map that we make onto the picture. So this is a map of Heron Island that we've created using satellite information and those unique fingerprints that I talked about earlier. So the yellow that you can see on the map is all of the sand on the island. The red is rock, and the light blue is all of the coral surrounding the island. Now, one of the other super cool things we can do is do this over really big scales. So the pictures you'll see here is the coastline of Australia, and it gradually zooms in as we move from left to right. And you can see once we get to the far right, we've got a map a bit like that of Heron Island. And it's all of the habitat on the Great Barrier Reef. So it tells us how much coral there is, how much sand there is, how much rock there is, and how much rubble there is. And this is really cool because this is one of the first ever habitat maps of the Great Barrier Reef that's ever been made. So often people think that there's not a lot to discover in science, but the Great Barrier Reef has been really heavily studied for a really long time. And to think that this is one of the first ever habitat maps made of the reef is really cool. So what do we do from these maps? Well, we can do a lot of things. We can measure how much coral there is and if this changes over time. We can work out how much seagrass there is and if there's going to be enough food for all of the dugongs. We can work out what activities we are doing as humans that might be impacting the marine ecosystem. And really, like one of my favorite parts is we can explore and map parts of the world that people have never even been to. So as humans, it's really important that we understand the world around us. We rely on a healthy earth for our health and well-being. And we need to know how what we do as humans impacts the world around us. That might be in a good way or in a bad way. And we don't even know how much coral there is in the world. So how do we know how much we are losing? There's still so much more to discover. There are parts of the world humans have never been, seen to, or studied, and we need all of the help we can get. So for everyone out there watching today, I want you to ask yourselves a question. What might you be interested in discovering about our Earth from outer space? So have a ponder on that, and that's the end of my presentation today, and we can move to some questions.
Joanna, what a cool gig you have, and you get to go to some very, very special places and use some very cool toys to get even more. I don't know if your setup is where you can see us again, but if you want to come out of screen share so you can, by all means do that. We've got some YouTube classes. We've got Mr. Shattuck's class live. We'll begin with one that we got in online, which is about exactly that. What else you can see? Can you see whales or sharks or any other big marine creatures from satellites, or is it just these sort of mega structures like the coral reefs we were talking about?
Yeah, so you can see whales and sharks, which is really cool. But one of the problems with them is that they move all the time. So as the satellite goes over, we might know where they are at one point in time, but as they move around, it can be hard to work out. But I do have some colleagues that did some pretty cool stuff where they studied sea cucumbers and stingrays from outer space. So they basically worked out what shape the sea cucumber was, and they taught the computer to recognize that over really large areas, and they mapped how many sea cucumbers there were.
Quick follow-up before we head to Mr. Shattuck's. Sea cucumbers are not very big creatures. Are these like fields of them?
No, they're tiny, yeah. So basically they like to live on the sand. So in the sand on coral reefs, they're quite easy to see because they're quite dark and they've got that cucumber shape. So you can pick them up quite easily in satellite images because they sit on the sand. And stingrays as well, they've got a very distinct shape, right? They've got their big wings. So they can be quite easy to work out.
I love science that would be like absolute magic to people like 20, 30 years ago. And this fits every bill. So thank you for that. Mr. Shattuck, we're going to head to Deep River. Come on in, 5-6s, and take us away. Hey.
If you were to step on a seahorse, would it hurt your foot?
If you were to step on a seahorse?
Yeah.
Yeah. No, they're not actually that spiky. So they look like they've got spikes on them, but they're quite soft. So it wouldn't hurt your feet. which is good. But it might hurt the seahorse.
I was just gonna say, try not to step on the seahorses, poor little things. But this is actually a nice segue into a question we got online, which is when you're diving in these places. And by the way, as an aficionado of dive photography at this point, the broadcast we do, Heron Island, it keeps coming up a lot. Like it's a very special place in the world. So lucky you. Are there any dangers you need to worry about? Poisonous creatures, toothy creatures, anything that you're thinking about when you're getting into the water?
Yeah, so there's not too much to worry about really, because the cool thing about the ocean is most of the creatures there, if you don't bother them, they won't bother you. So I know that a lot of people are probably thinking that Australia is really dangerous, and Australia has a reputation for having a lot of poisonous animals. But most of them actually just live down on the reef. So, for example, stonefish, they look really crazy. They've got this big, like, alien mouth, and they live down on the reef. But they're only actually going to hurt you if you step on them or poke them. So, if we just leave most of the stuff alone, we're pretty safe, which is really good.
Yeah, this is a nice lesson, not just for ocean travel, but pretty much with animals in general around the world. Most animals don't want anything to do with you. They will leave you
Yeah.
alone, leave them alone. Even shark attacks. And this is something that I'm going to stress because we're probably going to get a question about it. I mean, in the whole global ocean, every year there's like 5-6 shark attack deaths, and there's about 8 billion people in the world, probably a quarter of which go in and on the ocean every single day. So you're way more likely to have things like coconuts fall on you, or vending machines fall on you, or you're probably more likely to have seahorses come and attack you than you are to have a shark incident out on one of these reefs. So I'm really glad we got that point in. Thank you so much, guys. All right, one more YouTube, and then we'll head back to our live class with Mr. Shattuck. Is there a favorite thing that you get to do? You highlighted at the beginning of your talk that you have a bit of diversity in the stuff that you get to do on a day-by-day basis. Is it getting in the water? What makes you get up out of bed in the morning?
My favorite thing to do is definitely scuba diving. So one of the really cool things about scuba diving is it's like entering an alien world. All of these things that you don't see in your day-to-day life are floating around, and it's quite cool because it's very calming. You head down there, you're in your own little bubble with your mask on and just the sound of you breathing, and you get to see all of these different things that so many people never get to see. So that's definitely getting under the water is my favorite part.
I always like to harp on this when people highlight this as their favorite thing, that at 10 years old, you can get an open water diver certification, which is what I have. And it is, it's like black magic. It's 70% of the world that is now open to you if you have that certification. It's very limited time. It's not too much money. It is well worth it. Every diver can attest to the fact that it is like a whole different world under there and quite a magical experience. So I'm so glad that was your answer. Deep River, we're back to you. Come on in. Take us away with a second question.
What's the biggest shark you've ever seen?
Biggest shark.
The biggest shark, yeah. So I've seen a shark that was about 6.5 meters long. So what's that in about 18 feet long? If that conversion's correct, yeah,
Yep.
15 to 18 feet long,
Yeah.
and probably weighed about 300 kilos or 300 or 400 kilos. So it was a big girl, but she just calmly swam past me, had a look, and kept going on her way.
Did you say the species of the shark at the beginning of that? If so, I missed it. What kind of shark?
She was a great white shark.
Ah, it's the dream. Lucky you. And you weren't terrified flying out of the water. You're just letting her go by and see how it goes.
No, I just let her go by and have a look. But you know, there is when the shark is that big, you do have a little bit of a heart rate increase.
Of course. If I turned the corner and there was an elephant, I'd be a little concerned as well.
Yeah.
Joanna, we got a question about sort of scanning through the water to see the colors or changes of things. So as you go deeper in the water, some people may know the color changes. If you go deep enough, some colors just disappear outright. Red tends to be like the last thing that sticks around. So do you have to calibrate your satellite imagery or airplane imagery or anything to account for things that might be at different depths of the coral reefs?
Yeah, we do. So that's a really good point. So yeah, the light color does disappear as it gets deeper. And one of the things we're working on at the moment is we can only really map water to about 10 meters deep. So if you think about the whole ocean, if we're only getting the little section to 10 meters, there's still so much more of the ocean to explore. And it's potential that we might be able to do it in the future, but we've got a lot of people working on the technology to try and do that. So we do calibrate our sensors to water depth and through some algorithms. And then, yeah, we can't really capture any light that's sort of deeper than 10 meters. So think about all that world to explore that we still have to have a look at.
we're going to have to get down there with subs and people and all sorts of other stuff, which, again, next week, Oceans Week, we're doing a lot of programs on just this with some pretty amazing divers and roboticists. So stay tuned for that. On that note, one of our questions before we head back to Mr. Shaddix is where else this happens. So you talked about Australia a lot, diving, being able to calibrate that. Are there other places that you get to go personally that you'd like to share about, or that colleagues of yours might get to work on around the globe?
Yeah, so there's people working all over the world on this issue. There's teams in America and in Europe. They've done some really cool mapping down in Bermuda and the Caribbean. And out across Florida, there's heaps of seagrass maps out across Florida, and some really cool ones in Europe as well. So we get to work with people from all over the world. Most of my work focuses in Australia. But the cool thing about working with satellites is I can be in Australia, but be working on information from Africa or from Asia. So there's a lot of diversity in what we get to do there.
It's quite amazing that the international community is able to collaborate in that way. Like, it never ceases to amaze that if you get to be a scientist like Joanna, you get to work with the smartest, best people from all over the world on projects of international import, which is very, very cool. On the note of seagrass too in Florida, I'm so glad you mentioned the manatee dugong thing, because we hardly ever talk about dugongs, and it's just such a delightful, charismatic creature. So everyone should go look up a dugong when you're done, is the moral of the story. Joanna, time flies and you're having fun, so we're going to take just one more question before we wrap up. I want to note again, if people want to check out our site for more coming up, the Our World Underwater Scholarship Society, the incredible OWAS page, like our 5 broadcasts, including yours, are just so spectacular. They're all on our YouTube channel. So much to explore there. Can't encourage that enough for our audience. Now, we'll wrap up with one question from Mr. Shaddix, class 5-6s. Come on in and wrap us up. Hey, guys.
What was your favorite spot you explored, and what is the prettiest spot you explored?
Oh, yeah, that's cool. Yeah, that's a really good question. So one of my favorite spots that I've explored, if anyone can see the picture behind me, that is the deep reefs of the Southern Ocean. And one of the reasons that's really cool is, so we do some deep diving where we get to go down to sort of 70 or 80 meters under the water. And it takes us a lot of equipment and a lot of training to get down there, but we get to dive on reefs that look like this. And that's really cool because we're some of the first people to have ever actually been down there. And they are so beautiful and so pretty. And to be able to see stuff that no human has ever been before is pretty exciting.
I would say so. It's one of the joys in science, whether you're a geologist, whether you're a paleontologist cracking open rocks, diver, space explorer. Like, there's so many moments where it's literally no one has ever seen that before in human history. Not many fields you can say that for other than scientific exploration. So, Joanna, this has been so much fun. Is there any last message about your work? Anything you want to leave kids with before we say farewell today?
I think the big thing I want to leave everybody with is we haven't discovered everything yet. There's still so much more to discover and explore. And so getting out and exploring the world, you never know what you might find.
No better message than that. It's something that we hear from pretty much all our explorers. Again, famously, the oceans are less explored than the moon. So get out, go explore, get Joanna's cool job, whatever makes you happy. That would be fantastic. And again, check out the OWAS page for more. I'm going to bring in Mr. Shaddix's class to say a big thank you and farewell to me. If you're at home on YouTube and you want to scream and yell in your classes and annoy the principal, please do. That's always kind of fun as well. But Deep River, thank you so much, everyone. Have a wonderful day. Bye.